we're going to do the rest of our Unit 1 test questions. So we're starting with question 10 right now. Which of the following sets of numbers would represent the shaded region of the diagram? So looking at our options here, this tells us that it's our number system and how they're organized. I had this up on the board for the entire first part of the year, so let's make sure that we remember. The big outside box is going to be rational numbers. This is basically any kind of number. It can have a fraction or a decimal. It can be a percent. It can be positive or negative. Doesn't matter. It's a number. So those are rational numbers. Now, if you get smaller inside the box, the next little section that we have is integers. These are negative or positive, but they cannot have fractions or decimals. So something like -6 or whatever could go in there, but it could not have a decimal. And then inside even farther are our whole numbers. These can also not have a fraction or a decimal, but this time they can't be negative either. So only boring numbers like 3 could go in there. No fractions, no decimals, none of that. All right, and then the shaded part, since we filled out the whole thing, we know that the shaded part, which is this part right there, is integers. So C was the correct answer. Number 11, this is the same type of diagram, so I'm just going to we did like 2 different kinds for y'all, so square and circle. So this is rational, this is integer, and this is whole numbers. And then it's asking us which statement is true. Okay, I hate these. These are really complicated, but I know you can do it. Y'all are smarter than I am, so don't worry about it. Okay, A says all rational numbers are integers. So anything that's a rational number, for example, 6, -5, 15, 3.8, any of those rational numbers are integers also. So remember, integers can be anything negative or positive, but they cannot have decimals or fractions. So does that mean if I had like 3 6/10, could that be an integer? No, because integers cannot have decimals or fractions. So no, that's not true. Not every rational number is an integer. 0 is not a rational number. 0 is everything. It's in the whole numbers. The only thing it's not is something called a natural number. 0 is not a natural number, but that's not in our diagram that we use, so don't worry about that. All rational numbers are whole numbers. Again, we just talked about that. This is a rational number, but it's not a whole number. Whole numbers cannot have decimals or fractions, and they can only be positive. So whole numbers can only be positive. So 0 is a rational number. All rational numbers are whole numbers. Nope, we talked about that one. And the last one says all whole numbers and integers are rational numbers too. Yes, here's the whole numbers and here's the rational numbers, and they're inside of the rational numbers. The rational numbers controls everybody. It's everybody. So yes, all whole numbers and integers are rational numbers. So D is the correct answer. Okay, number 12. At her party, Dana served pizza. She shared 10 pizzas equally with her 8 friends. I like to draw a picture. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't really matter if I draw it perfectly. Whatever. Those are the pizzas. Here are the people. They have arms. I just don't want to draw them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so she is dividing up these pizzas among her 8 friends. Okay, she is not going to split up her friends among the pizzas. So that means she's taking these 10 pizzas and she is dividing them by her 8 friends. Another way to write that is 10 divided by 8. Okay, so 10 divided by 8. The 2 ways this is represented are the correct ways, so that means it would be D. You're not dividing the 8 friends into 10 pieces. That would be crazy. We're not doing that. All right, number 13. Which point falls in quadrant 2? So let's label our quadrants real fast. Remember, we can draw a giant C to help us. So since I started right here, this is quadrant 1. Then I went over here. That means this is quadrant 2. I went over here. It's quadrant 3. And this is quadrant 4. Okay, this is 0. Remember, these are basically 2 number lines that cross each other. So on the x-axis, all my positive numbers are over here. All my negative numbers are over here. On my y-axis, my positives are up here. The negatives are down below 0. Okay, -6. So go to -6 on the y-axis. And then 2. Oh, look at that. That's in quadrant 2. That was easy. Let's double check the others. So B says -4, -4. So I'm going to go to -4 on my x-axis and then -4 on my y. Nope, that's in quadrant 3. 1, 5. So 1 on my x-axis and then 5 on my y-axis. Nope, that's in quadrant 1. And then I have 3, so I'm going over here to positive 3, and then down to negative 2. Nope, that's in quadrant 4, so it's not that one. Yay, it's A. All right, number 14. Okay, what is the x value of the coordinate pair marked by the pentagon? Pent means 5, so that means something that looks kind of like that. Like that little house, because it has 5 sides, 1, 2, 3, 4, 5. Cute. In quadrant 3. So again, this is quadrant 1, 2, 3. And this is the pentagon. It wants to know the x value. That's where it crosses the x-axis. And how nice, they labeled your x-axis for you. It crosses the x-axis right here, and that was negative 5. Okay, so A. All right, now we have to figure out which statement is true. So remember, something that's really going to help you over here. As I move farther and farther to the left, I get less and less. As I move farther to the right, I get greater and greater. Okay, point A is greater than point B. No, point A is farther to the left, so it's less. Point B is greater than 0. Nope, it's to the left of 0. Here's 0. So that means it is less than 0. Point B is less than point D. That's true. It's farther to the left. Yay. And then let's double check. Point C is less than point B. Nope, point C is actually to the right, so it's greater. So C is the only correct answer. All right, number 16. Which of the following represents a number with a smaller value than the dot plotted on the number line? First of all, let's figure out what that is. Okay, so here I have a 0. Here I have negative 1. So this is going to be negative because it's to the left of 0. And it's halfway in between 0 and 1. So that's negative 1/2. I could write it like a fraction, 1 over 2. But I see everything is a decimal. So I'm going to say negative 0.5. Okay, we want something less than that. So we want something in this direction. Okay, 1.5, that's positive, that's not to the left. So is this. This is also positive. 1/2 is positive. Nope, that would be over here somewhere. My negative 1.5, that would actually be, I would have to go to my negative 1 and then go another. It would be in between negative 1 and 2, so that's negative 1.5. It's not that. Oh, just kidding. It is that because it asked us, see, this is what I was talking about. I got to read carefully, smaller than that. And then negative 25 hundredths. This is negative 50, so think about it like quarters. The negative 25 hundredths would actually be like right here. It would be right before our dot. So no, that is not to the left. This one is correct. Negative 1.5. Okay, which expression is equivalent to 1/9? Look, we didn't even have to solve it. We know that we would do the nerd of the donkey. My 1 would go inside, my 9 would go outside. But if I were to read that division sentence or this division sentence, remember we read top to bottom on a page. That says 1 divided by 9. This is my 1 inside the house. It's being divided. So it's 1 divided by 9. Fractions are not addition problems or multiplication problems. So A and B should be the only ones you look at. And then you want to make sure that they have them in the right order. That says 1 divided by 9. Okay, identify the point negative 4, negative 3. So remember, I always do, this is the x value. This is the y. So my x is negative 4. So I'm going to go to 1, 2, 3, 4. Here's where I need to be. And then negative 3 on the y value. So I need to go down to 1, 2, 3. This is negative 3. So it is point F. And that is it.